Why do puddles dry up? It seems like a really simple question to answer at the start, but it's actually a lot more complicated than most people think. The most concise explanation that we learned in elementary school is that the puddles just evaporate. This is true, but not in the way you might think. Consider this. Water's boiling point is 100 Celsius, right? Or 212 degrees Fahrenheit. And there's no place in the world where it's that hot every time after it rains. But the puddles, they still evaporate. That's still happening. So why is it happening? It doesn't make sense. There is a scientific explanation for why this happens. Let's start with defining a few things first. Why is water a liquid at room temperature? Basically, in these little water molecules, there are intermolecular forces keeping them together. And these basically are the glue that keeps water together. Solids have a lot stronger intermolecular forces, and gases have much less intermolecular forces. Above 100 Celsius, water is a gas, and under 0 Celsius, water is a solid. What scientists have figured out is that in small quantities, water can actually evaporate below 100 Celsius. What's happening is that air particles basically hit the surface of the water, and some of these surface molecules are able to escape that way as they impart the energy they have into the water, letting a particle escape. Let's use this to understand the concept of a boiling point a little bit better. Even at cold temperatures, outside, there's still little bits of water that are able to escape. At cold temperatures, it's still a lot harder for the water molecules to escape because the intermolecular forces are stronger when it's colder. We can visualize this through drawing two arrows. Let's imagine this water is about at 45 degrees Fahrenheit, or maybe 7 degrees Celsius. There's not a lot of water that's able to escape, and the evaporation generally happens a little bit slower. At room temperature, we can visualize this with two arrows that are pretty much equal. There's definitely more water molecules escaping than in this, but it's still going to be nothing compared to when water's actually boiling. When water reaches the boiling point, that's where we can start to see these bubbles, and water is really escaping really fast. Much more than the pressure from the outside. Why is this important? Well, to me, it helps me understand the concept of boiling point a lot better, and it can also help you understand pressure when you get into that a little bit later.